Hi friends, welcome to my channel Mathematics Idea. This video is also available in Hindi. यह वीडियो हिंदी में भी उपलब्ध है. If you are happy with the content, please press like, share and subscribe. Press the bell icon to get the notification. If you are first time viewing this channel, then I will suggest you to go through my introduction video first to understand the presentation structure of the course content. Today we are at workshop 2 session for mathematical induction. Okay, we are at workshop 2 session. Before this we had completed introduction of mathematical induction, detailed explanation 1, 2 and 3 class. After that we had completed workshop session 1. In workshop session 1 we had completed 7 types of problems. In this workshop session 2 is a continuation part of workshop session 1. Okay, so it continues from problem number 8 to problem number 13. Okay, workshop session 1 and workshop session 2 has a main motive for your board examinations. Okay, now let's get started with our workshop session 2 classes, and the question number 8 is on your screen now. Okay, yeah. So my problem is 1 square plus 3 square plus 5 square dash dash up to 2n minus 1 square. Okay, this is my LHS. LHS is sum of 1 square, 3 square, 5 square, 7 square, 9 square. In place of n, if you will put the number of term, then you will get those numbers over here. Okay, so this is my LHS. So LHS is sum of all those numbers. It's equal to n 2n minus 1, 2n plus 1 by 3. Okay, so the RHS is n 2n minus 1, 2n plus 1 by 3. We have to show that the sum of this entire series is equal to n 2n minus 1, 2n plus 1 by 3. Now let's get started. My first step is check step for P1. For P1, my LHS will be 1 square, which is equal to 1. Okay, my LHS is 1 square, which is equal to 1. What will be my RHS? My RHS will be, I have to substitute 1 in place of n. So it will be this whole divided by 3. Okay, n is 1, 2 into 1 minus 1 into 2 into 1 plus 1. Okay, so this will become 3, this will become 1, 3 get cancelled. So my RHS will be 1. So my LHS is equal to RHS. When LHS and RHS are same, that means my P1 is true. Okay, so this is my first step completed. Now come to second step, where we have assumed that PM is true. So once we had assumed PM is true, we will come up with a concrete statement. And what is that concrete statement? The concrete statement is 1 square plus 3 square plus dash dash up to 2m minus 1 whole square. Okay, this is the LHS of my concrete statement. This is equal to m 2m minus 1 2m plus 1 whole by 3. Okay, so this is my concrete statement which I had got by my assumption. Okay, now let's go to our main step, which is our induction step. So my induction step, I will write my LHS now. So my LHS will be 1 square plus 2 square plus 1 square plus 3 square plus 5 square dash dash 2m minus 1 whole square plus 2m plus 1 whole square. Okay, so what I had done, I had replaced n with m plus 1. Once I replace n with m plus 1, it will become 2m plus 2, and 2m plus 2 minus 1, it will become 2m plus 1, so 2m plus 1 whole square. Okay, now let us anticipate that how my RHS of this pm plus 1 should look like. So I will write it over here, how my RHS should look like. So my RHS, in my RHS I will substitute n is equal to m plus 1. So once I substitute n is equal to m plus 1, I will get m plus 1, 2m plus 1, 2m plus 3 whole divided by 3. So this should be the RHS which I will be arriving by proving this. So let's get started. So this entire m terms, these entire m terms can be substituted. These entire m terms can be substituted with this. So let's substitute that. It will be m 2m minus 1 2m plus 1 by 3 plus 2m plus 1 whole square. Okay, so this will be my after substitution. This will be my step after substitution. Okay, now I will take 2m plus 1 common. So 2m plus 1 is common in this. So I will get m 2m minus 1 by 3 plus 2m plus 1. Okay, now here once I will take LCM and I will multiply m and 2m minus 1. I will multiply m and 2m minus 1 and I will take LCM here. Then I will get 2m plus 1. It is 2m square. I multiplied m with 2m. So once I multiplied m with 2m, it will become 2m square and this will become minus m. Right? After that, 3 will be multiplied here. It will be 6m plus 3 whole divided by 3. Okay, whole divided by 3. So 3 is the LCM here. Now this 6m minus m will become 5m. So it will be 2m plus 1 2m square plus 5m plus 3 whole divided by 3. Okay, so 2m square plus 5m plus 3 whole divided by 3. Done. Now I will use this side of the board for further simplifying my RHS to get the RHS. Okay, further simplifying my LHS to get the RHS. So this is my desired RHS. Okay, so now I will do splitting middle term for this. To understand what is the splitting middle term, you see my operation classes. Okay, go to my operation classes and understand what is the splitting middle term. I will do that here. Then I will come up with 2m plus 1 m square, sorry 2m square plus 5m plus 3 whole divided by 3. So it will be 2m plus 1 2m square plus 2m plus 3m plus 3 whole divided by 3. Okay, so what I had done, I had splitted 5m as 2m plus 3m. In this 2m is common and this 3 is common. Okay, so let take those common terms out. Then it is 2m plus 1. Here 2m is common, so it will become m plus 1, and here 3 is common and it will also become m plus 1 whole divided by 3. Now in these two terms, m plus 1 is common. Okay, here 2m plus 3 and it is m plus 1. So it is 2m plus 1, 2m plus 3, m plus 1 whole divided by 3. Okay, now we had received to the RHS, we had arrived to the RHS what we had anticipated. We had anticipated that there should be m plus 1 term, m plus 1 term is there, 2m plus 1 should be there, 2m plus 1 is there, 2m plus 3 should be there, and 2m plus 3 is there. Okay, so by this we can say that Pm plus 1 is true. If Pm plus 1 is true, my conclusion is that Pn is also true. Okay, this completes our problem number 8. Now we will proceed to problem number 9. Okay, so my ninth problem is product of n, n plus 1, n plus 5 is multiple of 3. Okay, if I will take n any value like 1, 2, 3, 4, 5, any value of n, then n, n plus 1, n plus 5, product of these three numbers is always a multiple of 3. Okay, this is what we have to show, right? So this is one type of our divisibility problem. Whenever such type of problem is given, our LHS will be definitely n, n plus 1, n plus 5. What will be my RHS? Our RHS will be 3k. Okay, 3k, because it is a multiple of 3. So k is so 3 is the factor and k is the other multiple. So it is 3k. So 3k is our RHS. So we can write that this is equal to 3k. Okay. Okay. Now let's get started with our process. So first step of check process, P1. For P1, my LHS will be n, n plus 1, n plus 5. So I will substitute n is equal to 1. So it will become 1, 1 plus 1, 1 plus 5. So this will become 2 into 6, which is 3 into 4 in the form of 3k. Right? So it is in the form of 3k. What my RHS says? My RHS says that it should be in the form of 3k. And these LHS and RHS both are matching. Here value of k is 4. So as both of them are matching, we can tell that P1 is correct and initial check is done. Now, second, we have to come up with a concrete statement. So for Pm, we will write that m, m plus 1, m plus 5 is equal to 3k. Okay, m, m plus 1, m plus 5 is equal to 3k. Now you understood this? This is the concrete statement which we had derived for Pm by assuming that Pm will be true. Now we have to show that with this assumption our Pm plus 1 is also true. So go through our Pm plus 1. For Pm plus 1, what will be my LHS? In place of n, I will substitute m plus 1. So it will be m plus 1, m plus 2 and m plus 6. Okay, m plus 1, m plus 2 and m plus 6. Now my whole motive is I have to get this expression from that. I have to get this expression from that term such that I can put 3k in place of the expression of m, m plus 1, m plus 5. So how I will get it? So you split this m and 2 now. So let's keep this m plus 6 aside. So we will get here m plus 1 into m plus 2 into m plus 1. Okay, and here we are left with m plus 6. Okay, with this we had arrived to two terms which are m and m plus 1 here. Okay, we had arrived to those two terms. Now we have to get m plus 5. So we will arrive from this. So what we will do? We will put m plus 1, m plus 2, m plus 1, and we will split this as n plus 5 plus 1. Okay. Now we will multiply this with this m plus 5. Then we will get m plus 1, m plus 5 plus this m and m plus 1 is multiplied with this 1. Then it will be m plus 1 m. Now this 2m plus 1, it is multiplied with m plus 5. 2 m plus 1, and it is multiplied with m plus 5, and here this 2m plus 1 is multiplied with 1, so it will be 2m plus 1. Okay, are you getting it? So what I had done, first I had splitted this m plus 2 into m plus 1 to get this m and m plus 1 term. Now I had splitted this m plus 6 into m plus 5 plus 1 to get this m plus 5 term. So we had got this of our PM statement, which can be written as 3k. Okay. Now in this entire thing m plus 1 is common, so let's take that m plus 1 common. Now once this m plus 1 is common, you got here m, you got here 2 m plus 5, and you are having at last 2. Okay, so 2 is from here, m plus 1 is common. Okay, you understood this? So it will be 3k plus m plus 1 into, you just take out multiply this 2 with this, then you will get it as 3m plus 12. Okay, 2m plus m will become 3m, 2 into 5 is 10, 10 plus 2 is 12. Okay, so this is 3k plus m plus 1, 3m plus 12. From this 3 is common, let's take 3 common, plus 3 m plus 1 m plus 4, right? What is it? 3k plus 3 m plus 1 m plus 4. Now take 3 common from entire thing, you will get 3k plus m plus 1 m plus 4. Okay, you get k plus m plus 1 m plus 4. This entire k m plus 1 m plus 4 is a number. It is a natural number. Okay, where n belongs to natural numbers. So m also should belong to natural number, and k is also a natural number. So this entire thing will be, I will take it as lambda, then it is in the form of 3 lambda. Okay, once it is in the form of 3 lambda, that means Pm plus 1 is divisible by 3. Okay, so our Pm plus 1 is also true. What is our RHS? RHS is 3k. So 3 lambda, it may be a lambda, it may be a k, it may be any number. So it is in the form of 3k form. So we can tell that Pm plus 1 is true. Hence our conclusion is Pn is also true. Right? Okay, this completes our problem number 9. Let's move on to problem number 10. So my problem is a statement Pn which is 10 to the power of 2n minus 1 plus 1 is divisible by 11. So this is the same type of problem what we had solved in problem number 8. In problem number 8 it was divisible by 3, here it is divisible by 11. So my RHS will be 11k. In my problem 8 it was 3k because it is divisible by 3. Here it is divisible by 11, so my RHS will be 11k. Okay. Now my LHS is 10 to the power of 2n minus 1 plus 1. Okay. Now let's move forward to solve this problem. So my first step for check step is of P1, right? So what will be my LHS of the check step? My LHS will be 10 to the power of, in place of n I have to substitute 1 minus 1 plus 1. This is 10 plus 1. It will become 11, right? So it is in the form of 11k. 11 into 1. So it is in the form of 11k. What my RHS says? My RHS says that this entire expression is divisible by 11. That means my RHS should be in the form of 11k. So my LHS and RHS both are equal. So that means my P1 check is done for this sum. Okay. Now let's come to our assumption step where we will come up with a concrete statement. Let's write PM. So for my PM I will substitute n with m. So 10 to the power of 2m minus 1 plus 1 is equal to 11k, right? This is divisible by 11. This is what we had assuming. This is what we are assuming in our PM statement. Okay. So 10 to the power of 2m minus 1 plus 1 equal to 11k. Now let's go to our PM plus 1. In our PM plus 1, what we will do? We will substitute m plus 1 in place of n in our LHS. So what will be my LHS? My LHS will be 10 to the power of 2 m plus 1 minus 1 plus 1. Okay, so this will be my LHS. In place of n I had substituted m plus 1. So this will become 10 to the power of 2m plus 1 plus 1. Okay, right. I can write it as 10 to the power of 2m minus 1 into 10 square plus 1. Okay, 2m minus 1, this 10 square will become plus 2 here, so it is equal to 2m plus 1. Okay, so I can write it as 2m minus 1 into 10 square. Why I had written 2m minus 1? Because I want to substitute the value of 2m minus 1 from here, 10 to the power of 2m minus 1 from here. So it will be 100 into 10 to the power of 2m minus 1 plus 1. Now let's move on to our PM statement. From here we can get that 10 to the power of 2m minus 1 is equal to 11k minus 1, right? We had taken 1 to that side, then we got the value of 10 to the power of 2m minus 1. We will substitute this value over here, then we will get 100 into 11k minus 1 plus 1, right? So it will become 100 into 11k minus 100 plus 1. Okay, so I had multiplied with 100, so it will be 100 into 11k minus 99. Minus 100 plus 1 is minus 99. Now we can take 11 common from these two, then it will be 11 into 100k minus 9, right? So it will be 11 into 100k minus 9. Now similar to the 8th problem, I can substitute this 100k minus 9 as a lambda, then I will get it as 11 lambda. So my RHS is in the form of 11k, 11 into lambda, 11 into k, or any number. So that's why my RHS is correct. So that is my Pm plus 1 is true. So the conclusion is my Pn will be true. Okay, right. This completes the 9th problem. Okay, this completes the 9th problem. Now we will move on to the 10th problem. Sorry, this is the 11th problem. This is not a 10th problem. We had completed 10th problem earlier. Okay, so this is the 11th problem. I told that it is a 10th problem in my last question. So it is a 11th problem, right? So my 11th problem is x to the power of 2n minus y to the power of 2n is divisible by x plus y. So it is the same as what we had done in 10th, our last problem, right? So their last problem, it was 11. It was a multiple of 11. So we had made it as 11k. Here it is x plus yk, right? Okay, so let's get started. So my first step is of check which is of P1. So for my P1, my L.H.S will be x to the power of 2 into 1 minus y to the power of 2 into 1. So this is nothing but x square minus y square. So it will be x plus y, x minus y. So this is x plus y k. So what my R.H.S says? My R.H.S says that it should be in the form of x plus y k. So it is in the form of that. Okay. So my L.H.S and R.H.S both are equal. So my P1 is correct. So initial check is done. Now let's go to our assumption step. In my assumption step, I will write my PM statement. Now in my PM statement, what will be my L.H.S? I will substitute n with m. Then it will be x to the power of 2m minus y to the power of 2m. And this is equal to x plus y into k. Okay. I will further write my x to the power of 2m as x plus y k plus y to the power of 2m. Okay, why I had written this x to the power of 2m? Because I want to substitute x to the power of 2m in my Pm plus 1 statement. That's why I had written this statement. Now let's go to our Pm plus 1. In our Pm plus 1 statement, I will replace my n in the L.H.S with m plus 1. Okay, so it will be x to the power of 2 m plus 1 minus y to the power of 2 m plus 1, right? So my L.H.S will be again x to the power of 2m into x square y to the power of 2m into y square. Now what I will do? I will substitute x to the power of 2m from here to there. Okay, so my x to the power of 2m will be x plus y into k plus y to the power of 2m into x square minus y to the power of 2m into y square. So what I had done, I had substituted this x to the power of 2m, this entirely from my Pm statement, this statement. Okay, so I had substituted over there. Now you multiply with x square, then you will get x plus y into k into x square plus y to the power of 2m into x square minus y square into y to the power of 2m. Okay, y square into y to the power of 2m. Now I will take y to the power of 2m common from these two. Then it will be x plus y k x square plus y to the power of 2m x square minus y square. Okay, I had taken y to the power of 2m common from that, so it will be x square minus y square. Okay, and this is x plus y into k into x square. Now what I will do, I will split this x square minus y square as x plus y, x minus y. Then it will be x plus y k into x square plus x plus y x minus y into y to the power of 2m. Okay, so here you take x plus y outside, then you will get x plus y k x square plus x minus y into y to the power of 2m. Okay, so this entire term I can write it as again as same as lambda, which we had done in problem number 10. So it will become x plus y into lambda, right? So this will become x plus y into lambda. That means this entire term is divisible by x plus y. Okay, so see, I am not putting this formally. There will be some equal to signs over here and all those things. Those formal things you learn from your textbooks. Okay, those formal things you learn from your textbook. It is highly a procedural class. Okay, I am telling you how to use the logic or how to get the idea. Okay, this is what is the mathematics idea, right? So I am telling you the idea how to do the problem. Being formal, writing L.H.S equal to this, R.H.S equal to this, you can follow your textbooks. Okay, right. So with this we can tell that my Pm plus 1 is true. With this our conclusion is Pn is also true, right? This completes 11th problem. Let's move on to 12th problem. Okay, so my 12th problem is 3 to the power of 2n plus 2 minus 8n minus 9 is divisible by 8. Okay, so this is what the problem is. The problem is 3 to the power of 2n plus 2 minus 8n minus 9 is divisible by 8. Okay, now let's get started. P of 1. In place of n I will substitute 1. So my L.H.S will be 3 to the power of 2 into 1 plus 2 minus 8 into 1 minus 9. So it will be 3 to the power of 4 minus 17. So 3 to the power of 4 will be 81. 81 minus 17 will be 64. Okay, 81 minus 17 is 64. It is 8 into 8. So can I write it as 8k. Okay, so my RHS for this will be 8k because it is divisible by 8. Problem is it is divisible by 8. So it is 8k. My RHS will be 8k. Both of them are matching. That means my P1 check is done. Right? Now let's come to our concrete statement. In our assumption that Pm is true, we will come up with 3 to the power of 2m plus 2 minus 8m minus 9 is equal to 8k. Okay, now what we will do, we will get 3 to the power of 2m plus 2 value from this. 3 to the power of 2m plus 2 value will be 8k plus 8m plus 9. Okay, 8k plus 8m plus 9. So this will be value of 3 to the power of 2m plus 2. So what I will do, I will substitute this in my Pm plus 1 statement. That's why I am deriving this 3 to the power of 2m plus 2 value. Okay. My P of m plus 1 statement. So my P of m plus 1 statement will be 3 of, in place of n I will substitute m plus 1 plus 2 minus 8 m plus 1 minus 9. So what I had done, in place of n I had substituted m plus 1. So it will be 3 of 2m plus 2 plus 2 minus 8m minus 17. Minus 8 minus 9, it will become minus 17, right? 3 to the power of 2m plus 2, this is 3 square, so it will become 9. 9 into 3 to the power of 2m plus 2 minus 8m minus 17, right? 9 into 3 to the power of 2m plus 2 minus 8m minus 17. What is this 3 to the power of 2m plus 2? I will substitute from here. So once I substitute from here, I will get 9 into 8k plus 8m plus 9 minus 8m minus 17, right? So what I had done, I had substituted 3 to the power of 2m plus 2 from here, which is 8k plus 8m plus 9. So it is 8k plus 8m plus 9. Multiply with 9 in this bracket, then you will get 72k plus 72m plus 81 minus 8m minus 17. Okay, now 72 minus 8, it will be 64. 81 minus 17, it will be 64. Okay, so 72k plus 64m plus 64. Okay, now 8 is common in entire this one, so I will take 8 common. So it will be 8 9k plus 8m plus 8. Okay, 8 9 is 72, 72k, 8 8 is 64, 64m, 8 8 is 64, 64. So this entire thing will be 8 lambda. Entire thing I can substitute by lambda. That means my Pm plus 1 is divisible by 8, or it is a multiple of 8. So my Pm plus 1 is true. So what is our conclusion? Our conclusion is Pn will also be a true, right? This completes 12th problem. Okay, now we will move on to 13th problem. My 13th problem is, a statement Pn is that 2n plus 7 is lesser than n plus 3 whole square. So this is a type of inequality problem. Okay, so in this inequality problem, we had discussed this type in our detailed explanation class. Okay, so understand what is the inequality, please go through my detailed explanation class. Right, now let's get started. First, check for P1. For P1, my L.H.S will be 2 into 1 plus 7, which is equal to 9. Now, what will be my R.H.S? My R.H.S will be 1 plus 3 whole square, which is 4 square 16. Right? What I had done, I had replaced n with 1. So when I replaced n with 1, it will become, L.H.S will become 9 and R.H.S is 16. Okay. So when RHS is 9, LHS is 9 and RHS is 16, clearly LHS is lesser than RHS. So this my LHS is lesser than RHS, that means it is satisfying this problem relation. So that's why my P1 check is done. Okay. Now let's come up with my assumption step. In my assumption step, let's write PM. Now in this PM, just I will replace n with m. So I will get 2m plus 7 is lesser than m plus 3 whole square. Okay, 2m plus 7 is lesser than m plus 3 whole square. Now let's come to our main induction step, which is our Pm plus 1. In Pm plus 1, what will be my LHS? My LHS will be 2m plus 1 plus 7. Okay, in place of n I had substituted m plus 1. So it will be 2m plus 1 plus 7. Okay. Now I will further write it as 2m plus 2 plus 7. It will be 2m plus 7 plus 2. Okay, I had written 2m plus 7. Why I had written 2m plus 7? Because I want to substitute it with m plus 3. This 2m plus 7 is lesser than m plus 3 whole square. Right? So I had kept here lesser than m plus 3 whole square, and it will be plus 2. Okay. Now till this it was equal to, just this step is equal to this step is equal to this step, or otherwise vice versa. Here I had substituted 2m plus 3 is lesser than m plus 3. So definitely this will be lesser than m plus 3 plus 2. Okay, right. Now what should be my RHS for Pm plus 1? It should be m plus 4 whole square. So I have to get here m plus 4. Now let's work towards how to get m plus 4 here. This is lesser than m square plus 6m plus 9 plus 2. Okay, now in m plus 4 whole square, my middle term will be 8m. So I have to make this as 8m, and my units place will be, my constant term will be 16. Okay, here it is 9 plus 2 11. So I have to make that adjustment. So it will be 8m plus 16 minus, here it is 6m, I had written 8m, so I have to subtract it 2m. Here it is 11, I had written here 16, so I need to subtract by 5. Okay, so this entire term will become m plus 4 whole square. Okay, entire term will become m plus 4 whole square. Now this will become minus of 2m plus 5. Right? Are you getting it? Now this I told you in detailed explanation class also, but I will explain again. Suppose 2 is lesser than 8 minus 3. Okay, once we take out this minus 3 also, 2 will be definitely lesser than 8. Are you getting it? 2 will be definitely lesser than 8. Similarly here also, if Pm plus 1 is lesser than this entire term, then it will be definitely lesser than m plus 4 whole square, because it is negative of something. If Pm plus 1 is lesser than some smaller thing, then definitely Pm plus 1 will be lesser than bigger thing. Using that, I will come to a conclusion that it is lesser than pm plus 1. This entire thing is lesser than m plus 4 whole square. Okay, so this is what we had anticipated, right? When we substitute n with m plus 1, then we will get m plus 4 whole square, and we got that in our RHS. Okay, so with this we can say that pm plus 1 is true, and we conclude that pn is also true. This completes 13th problem. We had covered all varieties of board questions in this. If some problems are skipped, then the pure intention or the pure reason is I had thought that it is a similar problem which is already discussed in our classes, either in the detailed explanation class or in the workshop sessions. Okay, so with these two workshop sessions, workshop session 1 and workshop session 2, we had completed the entire board level question. Now there will be a workshop session 3 which will be of the higher level than what we are seeing here. So there will be further workshop sessions conducted for a higher level of problems. Okay, so if you are happy with this content, please press like, share and subscribe. For the further sessions of the workshop, stay connected. Thank you.